Good morning, sixth graders. It is Thursday, April 30th, and we are finishing up this packet today, and we will begin a new one next week. So let's take a look at these equations. And we have to solve for these variables. Remember, the variable is the, excuse me, the letter that's in here. So all the letters we have to solve for, okay? So I'm going to do an example with you. So let's take a look at 2x equals 5. So we're going to write 2x equals 5, and we have to solve for x. And the way we do that is, since this is multiplication, we're going to do the opposite. And what we do to one side, we have to do to the other. So to get rid of the 2 and get x by itself, we have to divide by 2. And then whatever we do here, we have to do here. And so you see, we can get rid of those 2's, and we're left with x, okay, equals. All right, so 5 divided by 2, we're going to write that out as 5 divided by 2. How many 2's are in 5? You can look at your multiplication chart. 2 times what is close to 5 without going over? And we find it's 2. 2 times 2 is 4. All right, so we have a remainder. So what we have to do now is add a decimal and add a 0 and bring that 0 down. Now we're going to bring that decimal up. Now how many 2's are in 10? Or 2 times what is 10? And that's 5. 5 times 2 is 10. So we find out that x equals 2.5. Or another way to say that is 2.5, or 2 5/10. Okay, 2.5. All right, so that should be fairly self-explanatory. How about if I do one more with you? 6 equals 1/2 c. I just want you to see that it doesn't matter if the variable's over on this side or this side. All right, I'm going to erase this so I have room to work. Hope you've got that down. So 6, oops, equals 1/2 z. So that's no different than, remember, because of the commutative property, we can switch those. So, whoops, 1/2 z. It wouldn't have mattered if we put 1/2 z equals 6. Since we are used to doing that, because we usually have to see the variable first, but not always. So I just want you to see that this says the same thing as this, okay? So first thing you might want to do is make this 6 a fraction. Do you remember how to do that? That's right, you put it over 1. All right, so now we have 6. This still says 6 equals 1/2 z. All right, to get z by itself, we have to divide. So 1/2 z divided by 1/2 will get z by itself. Z equals, all right, so now we have to do 6 over 1 divided by 1/2. All right, so it's going to be much easier if we write that horizontally, I'm sorry. 6 over 1 divided by 1/2. And now, do you remember how to divide fractions? This is only for dividing fractions. Change, flip. That means you keep the first fraction, 6 over 1. We change division, change to multiplication, and then we flip the second fraction. So this is going to be 2 over 1. Then we multiply across. 6 times 2 is 12. 1 times 1 is 1, and we know that 12 over 1 is the same as 12. Okay? So z equals 12. Okay, so if we put it in up here, 1/2 12, 1/2 times 12 change the Z. Oops, oh, rats. Z. Oh dear. Okay, that didn't work out very well, did it? Let me change the color so you can see it better. 1/2 times Z, which we said Z is 12, equals 6. Let's see if that's true. So this means multiplication, so 1/2 times 12, and how do we make 12 a fraction? We put it over 1, and then we just multiply across. 1 times 12 is 12, 2 times 1 is 2, and then down here, 12 divided by 2, so 2 times what equals 12? 6. So you see our answer is correct. Z is 12. All right, so go ahead and do that. So here, this is addition, so you're going to want to subtract 1.8 from both sides. Okay, 1.8 to see what you're going to get y. So if we subtract 1.8 here, since this is addition, they are just going to cancel each other out. So this will cancel each other out. You're going to be left with y, and y will equal whatever you get here. Don't forget to borrow. Okay? All right. All right, let's move on to the next one. If you have any trouble with that, just reach out and I'll help you. All right, we're going to skip the gold chest one. And we're going to go here to lots of lollies. All right, so lots of lollies obviously is lollipops, and they're calling it lollies. That's okay. All right, so let's take a look. We've got Francis and Rishi. So Francis is we'll put F for Francis. We're going to put R for Rishi. We're given a bag of lollies. They share them out evenly and had one left over. So what do we know about this number right away if we know that they shared them evenly, no matter what they were? We don't know the number yet, and had one left over. Do we know whether that's an even number or an odd number? I hope you said it's an odd number, because if it was even, they would share them evenly and have nothing left over. Okay? So we know that the number we're going to pick is an odd number. All right. Just as they had finished sharing them, their friends Kishan, not sure where they are from because I've not heard the name Kishan before. Haley I have, and Paul I have. All right. All righty. Okay, so just as they had finished sharing them, in other words, just dispensing or distributing them to each other, they haven't eaten them yet. Just as they had finished sharing them, their friends Kishan, or Kishan maybe, Haley and Paul came along. They wanted some lollies too, so the children shared them out again between all of them. This time they had 2 lollies left over. All right. So they put them all back together, the ones that they had shared here, and now they're going to share them among 5 people. Okay. We still know that it's going to be, I believe it's going to be an odd number. Yep, because, yeah. All right, so there's a couple of ways to do this, and I'm going to show you one, but I don't want you to use mine. Just use mine as an example. I want you to come up with another one, okay? So I had that the number was, I just guessed 13. So because I need an odd number. So let's take a look and see if that works. I got 6 here, 6 here, and then 1 left over. Okay, so 13 is an odd number. It can be divided evenly among three people and then have or 2 people and have 1 left over. All right, well, let's see if that works when there's 3 more people. All right, so let's see if 13 works. Let's see. So 5 goes into 13 2 times. So they would each get 2, 3, 4, 5, 6, 7, 8, 9, 10. 11, but there's 3 left over. So that's not going to work, is it? There can only be 2 left over. Okay? 2, 4, 6, 8, 10, and 3 is 13, but it says 2 left over. All right, so 13 is not going to work. So let's try another one. I'm going to erase this so that we can have room. I wish I could just erase part of it, but I can't. All right. Okay, so let's real quickly put Francis back up, Rishi back up, Kishan, Haley, and Paul. Okay, so we know we need an odd number. And notice that this says how many lollies could there be in the bag. Okay, so I'm going to solve for one of these, but there's more than one number because it says could. It can have more than one. So let's try 7. All right. So let's say 7. So 1. Okay, if they divide 7 here, that would be 1, 2, 3, 4, 5, 6, and 1 left over. So that fits here where it says they shared them out evenly and had 1 left over with the number 7. 1, 2, 3, 4, 5, 6, 1 left over. All right, let's see if it works for when their friends come along. 7. So we got 1, 2, 3, 4, 5, 6, 7. Aha, that worked, didn't it? Here we had to share them out again, and they have 2 left over. And so 7 works, okay? But I would try another number, okay? You know, you can count by anything. Count by 4s. If they each got 4, then 4, 4, 4. Let's see, would that work? 21. No, that one won't work. Okay, well, I'm going to let you play around with that. I know there's more that work, but you give that a go. All right, and if you have trouble with that, let me know and I'll walk you through another example. Okay? All right, so let's move on down here. It says, which one doesn't belong? Choose a shape in this picture that you don't think belongs with the rest. Explain why. Can you pick another shape and give a different reason? Guys, this one's just an opinion and you just get to pick whatever you want. There's really not a wrong answer as long as you give it a reason. So you could pick this one and say, this is the only shape that's shaded in. You could pick this one and say, this is the only shape that's half a shape. You could say, I mean, this is the only oval. I mean, there's so many things. So as long as you pick one and give a reason, that's all that they want. Okay? All right, I'm going to move on. All right, so whoops, I got to take this off. All right, so let's look at this. This one we're going to skip, and it's okay with Mr. Gregory. This one needs more one-on-one instruction where I'm right there with you. So we're going to skip this one, and that's going to be okay with Mr. Gregory. I will let him know. He knows I'm shortening some assignments. All right, down here, product. Product means multiply. So these are multiplication problems. So you're going to write this out. 21.2 times 0.02. Oh, I'm sorry, that's not very neat, is it? All right, and then you're just going to multiply the 2 like that, and then you're going to multiply the zeros. And just remember that when you count the decimals, it's 1, 2, 3 decimal points. So you come down here, 1, 2, 3 decimal point, okay? All right, now on this one, I would put this one up top because it's more digits. Remember, we can do that because it's the commutative property. It doesn't matter which way we, which one we put first. Okay, so this is going to be 0.004 times 2.05, 2.05. All right, and then again, you're just going to multiply the 5 by the 4, the 0, the 0, the 0, then come over here and multiply the 0, and then multiply. Make sure that you keep these in columns, and when you're done, 1, 2, 3, 4, 5 decimal point. So you come down here and go 1, 2, 3, 4, 5 decimal point. Okay? All right. All right, let's move on. Okay, even and odd. Can an even number divided by another even number times another even number ever equal an odd number? What are your thoughts? Well, the way to do this is just do several examples. I would just do 4 or 5 examples and see, okay, if you get the pattern of all even or some odd, whatever you get. So I'll give you an example of how to do this. So, oops, keep doing that, don't I? Okay, so if I said 4, that's an even number. Remember, your even numbers are 2, or any number that ends in 2, 4, 6, 8, or 0. So then the other numbers are any number that ends in 1, 3, 5, 7, or 9 are odd. So just remember your even numbers. These are any numbers. So like not just 2, 4, 6, 8, 0. Then you go to 32, 34, 36, 38. You see that? Any number that ends in those. All right, so we've got the even number 4 divided by the even number 2 times, let's do the even number 6. Okay? All right, so 4 divided by 2 is 2, and 2 times 6 is 12. So this is 12. So it is not odd. So there's one example. I would do at least 5 examples. Any even number by an even number times even. I've done 1, so I would do 4 more. And I think you'll see a pattern of whether they're all even or if they're any or odd. Okay? All right. Let's move on. This is similar to what we did before, and that is we have to get the x by itself. So we are just going to, this is multiplication, so we're going to divide. And then whatever we do to that side, we have to do to this side. And then this gets rid, this gets rid of these 4s. It leaves x by itself equals 32 divided by 4. You can look at your multiplication table. Remember, addition and multiplication are related. So if it says 32 divided by 4, and you think, oh, I don't know my division facts, that's okay. Use multiplication. 4 times what? The answer here would equal 32. So look at your sheet and what did you get? 4 times what is 32? I hope you got 8. So x equals 8. Okay? All right, I'm going to show you one more because I don't want you to think they all have to be in whole numbers. Down here, we would divide top and bottom. I mean, not top and bottom. You're dividing by 100, okay, because we have to get x by itself. Okay, so now we got the hundreds gone. We're left with x equals 26 hundredths. Okay, now I'm not sure whether Mr. Gregory wants you to reduce it, but I'm going to show you how to reduce it. So this can be the answer, but if he's asked you in his lesson to reduce it, you take your 26 hundredths and you say, oh, they're both even. See, they end in, here it is. So one ends in 6, one ends in 0, so they're even. So all even numbers are divisible by 2. So 26 divided by 2, if you were to work that out, you will find out that 26 divided by 2 is 13. And 100 divided by 2 is 50. Okay? So whether you write this or this, they're both right. I just wanted you to see that there might be a fraction in there. Okay? All right, let's move on to this visual pattern. All right, so it says, here's some peaches, okay? Below is a pattern of peaches in stage 1 to 3. So this is stage 1. Stage 1, stage 2, stage 3. And they want you to say what stage 4 will look like. All right, so what we've done here is there's 3 here in stage 1 and 1 over here across from the middle one. So this essentially is stage 1 right here. See, that matches that. So what they did is added 2 there on top and 1 over here. All right, so now this is stage 2, all of this. So this is 3. And, okay, so this, 1, 2, 3, 4, 5, 1, 2, 1, 2, 3, 4, okay. All right, so this is stage 1. Here's stage 1 in the red, and they added 2 and 1. So all of this is stage 2. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3. Okay. All right. So this looks like stage 2 if you didn't have that red there. So look again. They added 2 and then 1 here. Okay. So now we have to rewrite 3. 1, 2, 3, 4, 5, 6, 7. I'm just going to make 1, 2, 3, 4, 5, 6, 7. All right. Now we have to add 2 to the top because that's the pattern. And then this was part of stage 3. So added 2 to the top and 1 here. Okay, you see that? So that's stage 4. All right, so 2, 3, 4, 5, 6, 7. This should be 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, and then we added 1 more. 1, 2, 3, 4, 5. Okay. All right, so we did that. All right, now draw or describe what you think stage 10 will look like. Okay, so you can on a piece of scrap paper draw that out. All you're doing to each one is adding 2 up top and adding 1 over here. Okay, so stage 5 would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. See, this is stage 5. And then down here, 1, 2, 3, 4, 5, and we add 1. Okay, so that's stage 5. So just keep doing that until you get to stage 10. Label how many peaches there are in each stage. So here there's 4. Here there's 7. Okay, here there's 1, 2, 3, 6, 7, 8, 9, 10. And how many did we have here? 11, 12, 13, 14, 15, 16. Is that right? 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Oh, wait. Oh, my goodness sakes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Stage 5 was the blue. So stage 5 is, oh, I hope I'm not confusing you. Stage 5 is 16. Okay. All right. So, I'm going to show you another way that we can look at this so that we can down here, oh my goodness sakes. Down here it says we have to write an equation. So I want to show you a way to look at this so that it's easier to write your equation. Whoopsie. I'm going to try to get it all the way to 10, but I don't know if I will be able to. But you can do that on your paper. Sorry about that. These are supposed to be beautifully straight lines, and you can see it's not so easy to do. All right, so let's check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Close, because I have to use the first for the, okay, so, well, maybe, oh, I can't get rid of that, rats. So, oh yeah, I did. Okay, so this, S-T-E-P, step, that's the step. This is peaches, okay? All right, you'll be able to fit it in yours because you've got a little more room than I do. Okay, I hope that was an E. It was supposed to be. All right, so it does. They call it a stage. Yes, oh, I put step. Okay, this word should be stage. It's the same thing. Stage, step. It doesn't matter which one you put. Okay, so we're going to label the stages. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and we'll put 10 right here. All right, so let's see what we have so far. In stage 1, we have 4. So let's put that in there. Okay, in stage 2, we have 7. In stage 3, we have 10. And stage 4, we have 13. And stage 5, we have 16. So let's see if we can find a pattern, okay? So stage 1 was 4. How many more did we add to get to stage 2? We added what? 4 plus what equals 7? 3, right. So 4 plus 3 is 7, okay? Okay, so we added 3 here, right? Plus 3. All right, what did we do to 7 to get to 10? Plus 3. What did we do to 10 to get to 13? Plus 3. Are you seeing the pattern? Okay. Plus 3, and 13 to 16 was plus 3. So now you can see that it'll be easy for you to get to 10 without even drawing this, because we can see our pattern. 16 plus 3, what do you think that is? 19. I'm going to let you do the rest. So in stage 7, it's going to be 19 plus 3. And then after you get that number, stage 8 is going to be this number plus 3. Stage 9, this number plus 3. And then down here to stage 10. And you can see what you get. So you can answer this one, draw or describe what you think stage 10 might look like. You could draw this, or you could even draw the peaches out on a sheet of paper, but at least you see the pattern here, okay? All right, now we're gonna look at D. Let me change the color to something else. Let's use pink, okay. Try to write an equation to describe the relationship between the stage n, the stage number, this stage number, n, and the number of oranges. Now they're calling them oranges. Up here they call them peaches. Now they're calling them oranges. They look like peaches to me. All right. So, okay. So they're saying that n equals the stage number, okay? Stage or step number, okay? Number. This is a symbol that means number, okay? And then they're saying that P is for peaches. They said oranges, but they meant peaches, okay? So now we have to write an equation using those variables, okay? All right. So I had to really play around with this, guys. So I'm just going to give you this, and you'll see how an equation, when you fit these numbers in, it works. Okay, so what I found was 3 times the stage, okay? They actually didn't give us an answer key on here, so the teachers all had to do these, which is fine. That's perfectly fine. Okay, so 3 times the stage, or step, plus 1 equals P. And what you're going to find is no matter what numbers you pick to put in here, it's always going to work. All right? So let's take a look. 3 times stage 1, which is 1, is 3 times 1 is 3, plus 1 equals what? 4. That's what we've got here. 3 times 1 plus 1 equals 4. All right, let's look at stage 2. 3 times 2 is 6, plus 1 is 7. 3 times 2 is 6, plus 1 is 7. All right, look at 3. 3 times 3 is 9, plus 1 is 10. You see that? All right, if you haven't done your work yet for 7, 8, 9, and 10, let's try 10. What's 3 times 10? 30 plus 1 is 31. So you're going to find that stage 10 is 31 if you haven't already done it. So you can use this equation actually to fill these in, or you can add 3 to each of these previous ones. So anyway, I wanted you to see how the equations work and how this function table, how you use that. So the n is the stage, so all of these stage numbers will go there for n, okay? And when you multiply them and you add 1, that's when you'll get these numbers of peaches, okay? All right, I hope that helps. Let me know if there's anything else you need help on. Have a great day. And this is your last day of learning, so have a great weekend. All right, bye-bye.